welcome so much to this Pharma Workshop here on Friday, the 20th. I'm super excited to start the Pharmaverse workshop today. We have an awesome all-star cast for the instructors today with Ross and Ari, both who help with the Pharmaverse. And I think you are in very good hands for today's session. So I will pass it over to Ari and Ross, who's going to kick off the workshop for today.
Thank you so much, everybody, for joining, and thanks, Phil, for that nice introduction. First of all, I think we just need to address that we're unfortunately not Kenji-san from Bayer as originally advertised for the workshop. Kenji unfortunately had some issues with her computer, and that's why me and Ross are here instead. But we'll just do a small introduction. I'll just start out. Yeah, my name is Ari. I sit on the Pharmaverse Council. I work for Novo Nordisk. We've been spending a lot of time diving deeper into Pharmaverse and R for submission and so on. And today I'll just be kind of the light appetizer to the workshop and giving you an overview of Pharmaverse. And then Ross will take you through the actual workshop activities. But Ross, maybe you'd like to introduce yourself as well.
Sure. So firstly, thank you to Pharma for having us along. It's a real honor to have a day dedicated to Pharmaverse workshops. Like Ari, I'm one of the council reps on the Pharmaverse. I'm based at Roche. I work as the data engineering product family lead. And one of the areas of open source I'm maybe most familiar with is I was one of the sponsors originating the Admiral package, which we're going to show you a little bit later, along with some other Pharmaverse packages. So thank you, and back to Ari.
Thanks, Ross. So, as I said, we'll just go into Pharmaverse, what it is. Ross will take over and go through some packages. We'll do some exercises in Admiral, and then we'll put some closing thoughts for all of you. And I really want to show you some stuff here that we've now included in the web page. So one of the main questions we get is, what is Pharmaverse? Like, is it just a package? So we try to kind of highlight that Pharmaverse is much more than just the Admiral package is kind of being which is the most visible one. It's actually a huge collection of packages, and most importantly, it's a huge community of people who want to do much more open source in pharma. And we really also just want to use this platform to say thank you to all of those people who invest their precious time in actually collaborating across companies to help with these packages. And that's why we also put everybody who contributes, and I guess this is not even everybody, but to the packages that we have in Pharmaverse. You can go in here, maybe find yourself or find a package and check who has contributed to these packages here as well. And to highlight that Pharmaverse is not only Admiral, we also now include all of the packages here on the web page that are included in Pharmaverse. And basically now you can find help directly from the Pharmaverse webpage by just clicking this hex script that we have here. You can also find a lot of other good stuff in here. You can find information on how to contribute and also contribute at various levels, either to packages or just individual contributor, all the way up to being a council representative. And you'll also see some more detailed information on which packages kind of fit into which part of the end-to-end kind of clinical reporting pipeline. So there's a lot of good stuff in here, and a lot of more information about the packages. We also have several communities that we think you should be a part of if you want to stay up to date with what happens in Pharmaverse. We have a link to all of them up here. The most dominant one is in Slack, where we usually see a lot of good inputs from luckily not just only the council people, but all of the good people doing a lot of good package development, but also a lot of good questions around Pharmaverse and collaboration across pharma companies. And if you didn't know, we do actually have a Pharmaverse package. So the Pharmaverse package is not an umbrella package in the same sense that you might know from Pharmaverse, but this is really just kind of a guiding package. If you want to, for instance, go to the web page and explore more about what Pharmaverse is, you could just do Pharmaverse Explore. If you want to find the communities that we have, you could just do Pharmaverse Join, Slack, LinkedIn, GitHub. It will take you to the groups and use the invitation links for these groups if you want to join these. And then we have a web page with examples, and you can just use Pharmaverse examples to see the collection of examples that we have. And currently, we're revamping the examples sites. So if you use this one, you'll get into the old example site. But if you go into the example link on the web page, you would be redirected to an updated page. This will also be updated in the package. But before I hand it over to Ross, I just want to again, on behalf of the council, thank all of the people who invest a lot of time in developing these packages and to contribute to Pharmaverse in some way or another. So Ross, I'll give it over to you.
Okay, so in this talk, we really, there were so many things that we could share to become a Pharmaverse champion and to kind of kickstart this. But really, we thought we just wanted to give a flavor of the Pharmaverse, give you an early introduction into some of the packages for you to become familiar with. And then hopefully, as you delve into the other workshops later today, you get some broader experience of other Pharmaverse offerings. But as you can imagine, in 2 hours, there's only so far we can go with so many packages, so many different things you could learn. So what I'm going to start with is I'm going to show 4 packages today. I'm going to just do a quick walkthrough of how they all look and exactly what each of these packages offer and how you can delve deeper. Because I think the big thing we want you to come away from this workshop is not to feel like you're an expert in all of the Pharmaverse, because obviously that takes time, practice, and lots of reading. But we want to make people feel comfortable that they know where to go to find different package information and how they can just get started in just diving in, practicing on using any of these packages and just understanding how they fit together in conjunction to enable you to do common clinical reporting tasks. So these 4 packages shown here, they work, individually. They can do a lot of different purposes. But when you put them together, they could be an excellent tool for creating ESUB-compliant ADAM datasets for clinical reporting. So firstly, if I navigate back to the Pharmaverse website that Ari was just displaying, either via a hex wall, you could go from here to get to any of the package sites. But also, if you go to end-to-end clinical reporting packages, sometimes it's not always easy if you don't know the packages names or exactly what you're looking for. So we try to categorize them by common reporting tasks. So one example is kind of how we work with metadata. And there you'll see Metacore or MetaTools. And if you click the book, you'll get to the website. If you click the GitHub link, you'll get to the repo where you can see all of the code fully transparent. Other examples would be like utility programs, or there's even some programs specific for package developers. But the other ones that I'm going to show today, you'll find under ESUB. So we have Exporter, and under ADAM, we have Admiral. And it's worth saying here that Admiral is not a single package. It's an ecosystem, because for Admiral, this supports ADAM derivations. We have a core kind of common set of functions, which could be used for safety or for common analysis, which could be used across any disease area. And then you have therapeutic area specifics, such as oncology, ophthalmology, and vaccine. And we imagine this ecosystem will grow further over time. Okay, so with that, I'm going to jump to the first of the packages I mentioned, which is Metacore. And I'll just give a brief explanation of what Metacore offers. So the idea behind Metacore is we often need to use our metadata, our Adam specifications, for example, to drive things which occur in our derivations of Adam. But every company has their own form of these specifications. So you may use Excel, Google Sheets, a database, any kind of technique, but often we'll all be maintaining very similar information, but maybe in our own company-specific ways. Some companies will create define files, which of course is a standard, and they'll have that up front. But many companies don't create the define until late in the day at the time towards e-submission. So what Metacore offers is a harmonized layer to be able to store the specifications as our objects, which we can then feed into other packages to perform automated tasks. And if you are one of the companies that already create define right from the start, you'll notice that there's a reader function here where it can read directly from define.xml 2.0. What it actually looks like in Metacore is they have these separate objects for different purposes. So one has the basic information around each data set. One has the variable level metadata. So it has things like the order, the variable attributes. And as you go down, you basically see that there's things like control terminology, supplemental qualifiers. So you kind of see how by this image, all of these objects fit together to give you your complete, a complete representation of your Adam metadata, but in a machine readable format, which is potentially standardized now across the industry. So packages can be built on top of Metacore to use these objects as input to automate common programming tasks. So I'm going to close that one because the next one is MetaTools, which basically does that very same task. So it uses the output of Metacore, which is these harmonized spec objects, and now it performs certain derivation tasks, which can enable you to set up your parts of your Adam. So there are some examples which I will show a little bit later, but there's a lot of great examples within this package. So there are things like where you take in your specification and say you're taking common variables from SCTM, but you have to rename them in your spec to a new name in Adam, or you're applying a controlled list. There are functions there which can just kind of take what your specification is asking you to do and build a starting point to your Adam. It doesn't go into the kind of very deep derivations or challenging derivations, which you would use Admiral for, but it can be a really good starting point to use some of these functions to give you a starting point of building your Adam, so that maybe some of the easier tasks you don't want to have to do manually, you can do them direct from your specifications. It also does a lot of useful check-in, which we'll come to later, and I'll show you an example of how that could be really useful. So that's MetaTools. Then you have Exporter. This is, at the moment, as an industry, we usually submit in transport files, usually version 5, so commonly known as XBT files. And Exporter is an enabler to convert from our datasets into the XBT file, and also provide some ESUB conformance checks. So this can be a really useful thing prior to Pinnacle 21 or CDIS Open Core, whatever you're planning to use for your conformance checks. Some of this can actually help you to identify things proactively as you're setting up your Adam, so that when you do come to any other downstream conformance checks, chances are you've already addressed those issues right from the start when you're building this. One thing I should always segue when I talk about Exporter is there's a lot of great work in the industry now around looking at other data formats that could be used for submission. And I know colleagues from Atoros and other companies like J&J have been collaborating around a dataset JSON R package. The dataset JSON initiative is still in its infancy, but that's another really exciting area. And at the moment, we're looking at bringing some of that work under Pharmaverse as well. So that dataset JSON R package would be available similar to Exporter, so that we can also create dataset JSON if the industry kind of continues to go in that direction. And last but not least is Admiral, which will be the focus of our hands-on session today. And with Admiral, it's really a bit of the specifics around creating Adam. So a lot of people would say, and we got this right from the start with Admiral, people would ask, why doesn't Admiral cover all the metadata pieces? Why doesn't Admiral create an XPT? And in many ways, we could have put all of those other free packages that I showed all under one roof with Admiral. That's really not the R way. It would have made it much more difficult to maintain, and it would have also made it more difficult to iteratively enhance. So really, this is the joy of the Pharmaverse and joy of R in general. Each of these packages help to extend the offering, and when you put them all together and you use them in conjunction, they can be really powerful to help you to get to the ultimate endpoint of what you need, which is Adams. So with Admiral, the main things to mention, the user guides are very thorough, really well documented, talking you through step by step how you create common Adams piece by piece. At the bottom of each of these, there's also a link to templates that you can use that will pull all of the Adam functions together step by step to show you how you can build different kinds of Adam. And then when you need to dig down into any individual function, you'll find that there's a wealth of documentation around all of the arguments used, and also plenty of examples to help you to understand, based on test data, how that function performs and what's the ultimate output of each function. So one of the things that we hope you notice when you're using Pharmaverse packages and Admiral as well is that ultimately a lot of effort has been put into documentation here to try to make it as easy as possible for you guys to pick these off the shelf and to be able to get started performing the tasks that you need. So that's Admiral. And I'm going to jump next. I was going to show you here a video that we use at Roche, which shows how we've internally implemented these packages together. The video wouldn't quite work, so I'm going to show you instead via an offering we have in the Pharmaverse open source. So on our website, when Ari was showing you the top bar, you might have seen there's one of the options there was examples. If you click that, you get open to this section, which shows you this is an examples quarto book we're working on, where this will show you how you can use different Pharmaverse packages together to perform common clinical reporting tasks. Phil and Posit are working with us in that we want to eventually add a Posit Cloud option to this repo, so that if anyone ever wants to go practice on these examples, you don't just have to look at how we've set them out in our articles. You can also open Posit Cloud and actually try working with all of the code yourselves using test data. That's something we're working on in the near future. This book is a work in progress. We will add lots more over time, but bear with us. Also, if you're interested to contribute to this and anything across Pharmaverse, as Ari showed, there's plenty of ways that you can get involved, and we're always willing and open for contribution. So here's an ADSL example, and it goes over the 4 packages I showed, and it uses some test data from the Pharmaverse SCTM package. So if you click code on each of these, you can either show or hide the code blocks to kind of see which bits you're interested in. The first bit is all around Metacore. So here we just have an example, Adam spec being read in, and creating Metacore objects from it. On the Metacore website, there's some really great articles around what do you do if you have a company-specific ADAM specification, and they show you how you could create a reader function to basically convert it into the objects they need. So an example is we showed when we talked at the Metacore website, there's this DS vars. So this is basically keeping some of your high-level information for each variable, which then could be used to automate. So in this case, it shows you your key variables, the order that they will be shown as columns in your data set, and some other specific flags that can be used. So a very basic example of how this could be used in your ADAM is just in ordering. So sometimes when we're creating our final ADAM, we realize that for some reason, ARM has been created as the first variable and it's showing as the first column. Obviously, we always want the first columns to be our patient identifiers, like study ID, USUBJ ID. So just having that order there, that can feed into a downstream function that automatically shows all of the columns in the right order. So it can be simple as that, or it can be things like sorting the data sets, different things like that, which will come from this metadata, but will affect your ADAM to make it correct based on the specification. One of the powers of doing this, and I'll show you a little bit later at the bottom when we get to the checks, is the more you take from your specifications to control what goes into that ADAM, to control how the ADAM is derived, the less checking you have to do manually to be sure that the user has selected the right things. Because all you really have to do is review your specifications, and if it's correct there, you'll know that the data set will match. Then we start building derivations. So this section talks you through MetaTools, and it gives you some examples of certain MetaTools functions. And if you want to know more about any of these functions, of course, you just look into the MetaTools website and go onto their reference page. But it shows you some basics of how, for example, you could create like an age group variable. So an age group variable would often come from the analysis age, but then categorized into certain groupings. You could do this yourself with a simple case when statement, but if you set your specifications up with this in a way that Metacore and MetaTools can read, then actually you can just do it with a MetaTools function that automatically creates that decode for you. Then if I drop down to the Admiral section, and we don't show all of the Admiral derivations here for an ADSL, because we have a whole vignette for that in the Admiral guide. So it's not about showing how everything you could possibly do with these packages, but it's just showing how, for example, they could be used in conjunction. So here shows a few Admiral derivations, and we'll practice some of these in the exercises later. And then when you get to the bottom, this assumes you have your final ADAM now. It shows you how some of the functions from MetaTools and Exporter can do some really nice checks on your data set to make sure that you're in line with your specifications. So there's things like checking all the variables are specified and no more. That can be quite a common thing where you realize you actually missed a variable from the spec, or you've included a temporary variable which you meant to drop. It does some really nice checks on control terminology. So does your spec include all of the control terminology terms that your data has, and vice versa? Is there terminology there that's missing in your code list on your specifications? I mentioned ordering columns and sorting rows. And then there's also pieces around when it comes to converting the R data set into a XPT file. There's some kind of SAS specifics there around things like you could do export a format, which isn't shown here, to apply a format, but you can also check that the types make sense. Are you suddenly trying to take a date and make it a character? And you need to be aware of the change that you're making there. So all of this can kind of take things from your specifications and ultimately use that to help you make ESUB compliant XPT files. And then at the end, you can use this function to write that out. So that shows you kind of piece by piece, just a basic example of how all of these packages are used together to create Adam. Okay, the other piece that I want to show at this stage is I wanted to make reference to the R Consortium submission pilots. So if anybody isn't aware of these, please just Google, take a look at their website and their excellent repos. It's all open, very transparent. But they're doing some really great submission pilots with the FDA around showing that it is possible to submit things fully created in R. One of the examples here is Adam, the recent pilot 3. And if you go into the submission, you can either look at the Adam and you can see example XPTs that they created, or you can look at the programs. And what you'll see if I open up ADSL.R, you'll see that a number of the packages that I've been showing you there have actually been used in this submission. And you can see the example full code of what has been submitted here and how they've created XPT, which have gone as part of this pilot to the FDA. So I think this is really worth calling out because a lot of people talk about the move to open source, the move towards R as being something many years away and an exciting kind of distant frontier. But here you have examples where true pilots are being worked, where the FDA are actually themselves collaborating to see that it is possible and to open up the industry to new avenues and new ways of doing submission. Ari, my colleague on the call today, also recently did an excellent webinar around Novo Nordisk's journey to their first submission in R. And that's another great video that is worth watching to show that the industry are really embracing this direction. Okay, so that's all the examples that I wanted to share and just a kind of basic walkthrough to show you some of the packages we can use for Adam and why we use them in conjunction. Apologies that I wasn't able to get the Roche video to work, but I think that examples page shows you just as good information. One thing I will say on Roche is that we are embracing R as our primary backbone for all clinical reporting. And we have a lot, definitely going into next year, we have more and more teams moving that way. So we are very, very much heavily invested in all of these packages that we show today and using them as our default to produce all Adam in future. Firstly, you'll see if everybody, if everyone has managed to open that exercises.r that Phil showed, you'll see this top section. So all this is doing is gonna load the packages that we need for today. All of them should be pre-installed for you. And then we're just gonna load up some test data. So we're gonna take demographics, disposition, exposure, and adverse events. So these are all test data, SDTM. And what we're gonna do is we're gonna run one function from Admiral, which does the convert blanks to NA. What this basically means is because this test data, it wasn't kind of set up with R specifically in mind, you do have blanks instead of where R would expect an NA. So all it does is it sees any blank, any missing value, and it will replace that with an NA. So if you navigate to your session, you can highlight all of those first sections, so those first 15 lines, and you can run that. And in the top right-hand side, the environment, you'll be able to open any of these data sets as you go through the exercises so that you can explore what you've created at each stage. So here you'll see the AE data set, and you'll see where before it would have been blank. Now you have these NAs, which is more the R default. Okay, so let's move to our first exercise once you've got that run. So we're going to give 10 minutes to try this out. what I'm going to ask you to do, all of the exercises are based around common derivations you would see in ADSL, which for anyone unfamiliar with ADAM is the subject level analysis data set. And what we're going to do is, firstly, we're going to create a new data set named ds_x. We're going to take everything from ds, and we're going to convert the DTC date variable, so the ISO 8601 date that we often store in SDTM, and we're going to convert that to a numeric DT date, and we're not going to apply any partial date imputation. The way you're going to do this is you're going to use this derive vars dt function. And the way to find that is if you're on, say you're on the Pharmaverse website to start, and you navigate to Adam, you open up the Admiral website, and then under the reference page, you can either control find, or you can navigate down and you can find the function page. All of the functions are also categorized depending on what they produce. So if you're ever unsure, you can also use this categorization to help you find things you're looking for. If we open derive vars dt, you'll see what are the defaults for each argument, what does each of the arguments mean, and then some examples of how you might go about creating different date variables using this function. So with that in mind, that's plenty to get you started. We're going to give you 10 minutes. And if you can just go to the exercises.r, and here's the exercise. It's there in the comment. And you can just use this section to play around, try to add code to create this. And then I will show you a solution in 10 minutes. So we're going to start the clock, and best of luck. Yeah, there's some really good questions, so I'd like to address them before moving on. So one question I saw from Reese was that his company and many other companies have the same, where they kind of taken the SDTM CDIS standard, but then they made their own kind of company-specific implementations. And he was asking kind of, is there any learning with that? You're definitely not alone, Reese. I think most companies, because the CDIS standards go so far, but they don't kind of give you a perfect way of like, this is the identical only single way to do things. So a lot of the time companies have to make choices. I'd say SDTM as a standard is much more structured and rigid than Adam. Adam is very kind of open to interpretation. But yeah, every company has that kind of challenge. What I would say, like the beauty of Admiral is we didn't try to do this in a single way that kind of restricts you to only, to always having to have things an exact way. A lot of this is like modular solutions, these individual building block functions, so you can actually adjust them for your needs, because every company likely does this, has slight differences to the way. And what we did is we started with Roche and GSK, two companies sharing their different approaches, kind of trying to find a centralized kind of high level way that we could achieve both. And then very early on in the infancy of Admiral, we shared this with 20 other companies to get their input and their testing. So they all had their own various implementations of SCTM, but they tried the Admiral functions to use them, and they fed back to us places where we were being too rigid and we weren't accepting enough kind of variation that could potentially happen in the industry. So over time, Admiral's become what it is. But you can take Admiral and you can definitely then build a layer on top of it. So for example, at Roche, we have Admiral Roche, which takes all of the Admiral functions, but implements them according to our standard rules. So our standard ways that we receive input SCTM and the rules that we apply for our Adam. So hopefully that helps with your question, Reese. The other really great question was for folks that are new to R, sometimes they get confused when, what we could have had is you could have had every function I could have written like this, which would have shown you exactly which package each function should come from. But in the examples, I haven't done that. I've just given you the actual function names. So the question was, how do I know where that function lives? Which package is it from? And a really nice way is just this double question mark in R. And if you run that, you'll have the help page in the bottom right, which will try to find that function for you. And then you can open up this, and it will basically open that same function page that I showed directly from the Admiral website. So that's a really nice trick to remember. Okay, if I jump to that page, because it's a little nicer to view on the website, what you probably would have first done in that exercise, hopefully, is started to read through and try to understand all of these arguments. Apologies, but none of these arguments were even needed in this exercise. It was a really simple exercise where really you just needed to change these two things. But I wanted to show you something here because I thought it's worth, when you dig into a function, you really want to understand what's the true capability of that function. Because to give you the task that you had, just creating a DT from a DTC, it's not rocket science. But actually the power in Admiral is all of the other things that you may need to do in different kinds of implementation of dates, which you can now do from this function. So there was a whole host of different partial imputations you can do. You could create the DTF variables. So these are the CDISC Atom like imputation flags. If you choose to impute, you can get those flags that are needed. You can set dates which you want to be either the minimum or maximum you can impute to. So for example, maybe a patient died and you know their death date, so you don't want to impute a partial date to be after their death, because that wouldn't make sense. Or maybe a data cut, something like that. You can actually set a max date, so it will never impute over that date. Or a min date, it would never impute before that date. And there's also pieces where you can preserve. So say you get all kinds of odd combinations of partial date, which bits do you actually want to overwrite? Imagine you only had a missing month, but you have a day. That's pretty weird data if you had that. But if you did, do you want to preserve that day? Or do you want to impute all of them, up day and month up to a stage? So there's lots of different options here dependent on how your company choose. And it may be different for different atoms, for different derivation needs, even for different studies. But you have the flexibility within this function to pick and choose according to your needs. So let's jump into the exercise solution. So the exercise solution actually was really simple. It was taking the DTC, and you probably could have guessed what this argument meant because it's called DTC. And then this one, again, pretty readable. What do you want the prefix of the new variable to be? It's going to get a DT added at the end because this is a DT creator, and CDISC always expects you to use that prefix, or no, that suffix, I should say. So here you just give the starting point, and that means it's going to create DSST DT because it will always add the DT on the end. So if we run this, you now have a DSX data set, and you have the DSS DT created. Of course, it's not easy viewable that this is a day and this is a character, so you can check the class of each of these, and you can see that the DTC is a character, the DT is a date. I should say that all of the solutions are in this solutions.r file, but try your best if you can as you're working through just to use the Admiral reference pages to see if you can figure it out yourself first and then see how it goes. The other thing I should say is all of these examples are actually part of Admiral vignettes as well. So here, there would be examples if you scroll up, and this is the ADSL, creating a basic ADSL user guide. And this will include all of the examples that we're doing today, and actually a lot more. They're all included here with not only the code, but also examples of how the data set you produce would look. So everything is available for you to go away and practice on after this workshop so that you can really master these functions. Okay, let's jump to exercise 2 then. So exercise 2 is going to be using that date variable that you just created So if you didn't manage to do that, then go over to that solutions file, copy the code in and run it so that you make sure you have your DSX, because you're going to need that as input for this. And the next thing we're going to do is we're going to take DM as input. We're going to create an ADSL_1, and we're going to derive an end of study date. And we're going to call it EOSDT. The end of study date is going to have to take the records from DSX. And what you're going to do is you're going to look for a filter on that to see where DSCat is disposition event and DSDcode is not equal to screen failure. So for anyone new to R, that exclamation mark equal is just not equal. So you're going to filter your DSX data on this, and you're going to merge it in so you get this extra ADSL variable added to DM, which is going to be called EOSDT. And to do this, you're going to use a function called derivVarsMerged. So again, if you're on the reference page, you can either scroll down or you can control find, and you'll see this derivVarsMerged. And this has a lot of options. So have a read through the options, decide what you think you need to do, have a look at the examples if you get stuck. And as before, we give you 10 minutes and then we'll show the solution. Starting now. Okay, so this was derivVarsMerged. So let's have a look at the solution. So in this case, there was a really good question around kind of piping in R around, firstly, not overriding the same name data set. So I can explain, like in Admiral templates, I think they went quite simple and they kind of always overwrite the same ADSL. But in the Admiral Roche implementation, we definitely didn't choose that route because it's way easier to debug code if you space it out and you block it with different data sets created. So what we do is we have a block of functions that produce similar related variables. So we'll have like a block of disposition and we'll call it, say, ADSL_disp or something like that. So, there's 3 or 4 variables created, and then we'll feed that into the next one, which could be like ADSL_ last known alive day, or, whatever's next. So yeah, we definitely do use piping. The other thing was that data set argument that they all have. You can either feed in the data set there, or if you're piping, you don't have to. You can say, I want to affect this data set with this function. So this is personally my preference. I always prefer doing it this way. So let's have a look. So you got ADSL1 you're creating it from DM. derivVarsMerged kind of does what it says on the tin. It's basically just merging variables from another place, or it could be even merging variables from the exact same data set, but it's basically taking 2 data frames and bringing them together. A lot of people will say, why don't you just use a left join from dplyr here? And equally, Admiral's very open. You could, if you're happy with just dplyr code, but there are some options here very specific to things which would be useful when you're doing such add-on derivations. So we hope this adds value. But definitely, if you're more confident with dplyr and you don't think this is value add, you of course don't have to use it. In this case, it's taking ds_x, the data set that we just created last time. The by variables, we're just going to do study ID, usubj ID. In a true specification, that might have been added. I didn't put that in. I thought everyone would probably assume that I meant just to either do the by variables as usubj ID or study ID, usubj ID. I mean, that's pretty common in Adam. You're going to create a new var. And in this case, we're just creating one variable, which is EOS date, and we're creating it from this date. So essentially, you're doing like a rename here. And then the filter add is the kind of where clause, the kind of filter that you want to apply to that input extra data set. You could have done this in multiple steps. So you could have filtered first and then kind of done the merge. But in this case, it's quite nice that it's all done in kind of one nice cohesive block. So if we run that, we're going to get an ADSL_1. And you got this EOS date added at the end. And you'll see for the screen failure patient, they didn't get anything added because we had that as part of our specification to ignore screen failures. Okay, so let's jump back to the next exercise. The next exercise, we're now going to be creating an ADSL_2 from that ADSL_1 you just created. And now you're going to do a really common derivation, which is the safety population flag. And you're going to set the variable as Y for any patient from EX, the exposure domain, that has a record where EX dose is greater than 0. So we've gone for a really simple safety derivation here. In practicality, there might be more complexity than this, but just for the sake of this. And we're going to use a new function based on derived vars merged, but it's called derived var merge exists flag. So again, go back to the reference page. You'll know by now how to find it. Open that page up, have a look at the function, and try out this this exercise. So I will start the timer, and Phil, back over to you. Okay, so let's have a look at the solution to this exercise. So this time we were using derived var merged exists flag. So essentially, this is merging from another data set, but it does the job of creating an existence flag. So it's basically saying, hey, let's set something to Y if a certain condition happens in that data set. So this can be really commonly used in many Adam places. Imagine like a flag for, did the patient have an AE that led to withdrawal? Did the patient have a death? Did the patient have XYZ? Any scenario you could imagine needing to use such a function. So all we're doing is the same as before. We're taking this additional data set, EX. We're using these bi-variables as our identifiers. We're creating a new var as SAFL, safety flag, and the condition is EX dose greater than 0. And we're going to run that. And what you'll see now is in ADSL_2, you get the new flag SAFL with a Y or a blank. What you'll notice here, if any of you did delve into the data, probably the derivation we used wasn't very appropriate because it left all the placebo patients as missing, when in reality, I guess they set up this study that placebo would always have EX dose equals 0. So we were excluding those records from EX. So in reality, this is a case where you'd probably want to adjust your specification and maybe add an or condition, say like or EX treat equals placebo, or something like that to allow for that specific derivation. Okay, so let's move to exercise 4. This one's probably the most tricky of all the exercises. So Phil, let's give the full 10 minutes for this one. We're gonna create an ADSL_3 with all of ADSL2, what you just created, plus we're gonna derive a last known alive date called last alive date. And for this one, in reality, last alive date usually use many different STTM date sources, but for simplicity, for the purpose of this demo, we're just going to have it as take either the latest of the AE start date or the AE and end date. But to add a little bit of fun, we're going to ask you to impute those dates in case there was a missing or day and month to the first available. So it would be 01 for day or Jan for month. So have a look at that. You're going to have a look at the derived var extreme date page. And that's not going to be the only function you're going to be using as part of this exercise. Have a look at the example, see if you can figure it out. And in 10 minutes, we'll go over the solution. Cool. So hopefully you can all see my screen again. So yeah, just a reminder that all of these exercises, or like a variation of the exercises, are all shown in the ADSL vignette. Usually the ones here are kind of even more realistic because, for example, if you look at last known alive date, it actually shows kind of like 4 different dates that you might want to use for that instead of just the 2 that I shared in this exercise. So if we navigate to the solutions, this is kind of some of the areas where I don't know if you guys saw Ari replied to a comment earlier in the chat. Most of Admiral is definitely very like functional programming based, but there are a few cases where we use like object-oriented programming. Please don't ask me questions about that. If you do, put it in the chat and Ari can answer, because I'm definitely no like computer science expert. But the way that we do this in Admiral is we create these objects that can then be fed in to certain functions in order to perform a task. So in this case, we've got the AE start date here, where we're not creating this as a data frame, a data set. This is getting created as an object. It's essentially a kind of a list of information that then this function can digest and ultimately provide the derivation and the outcome. So here, what we're saying is we're going to use this this data source function that's going to create an object for us, which is going to use the data set named as AE, and it's going to take in this date, which is AE STDTC, but it's now converted to DT, and it's got the highest imputation as month. So it's going to impute month and date. Notice that we don't have to say the date imputation as first, for example, because that's the default argument here. You could put that if you want for clarity. So as you kind of, the other cool thing about R, if you're going to hover over, it shows you all of the defaults there of the function. So you can see that yellow box opening, but we don't have to overwrite the default there because we're happy to take this as the first of the month, the first day, if it's missing or partial. So here we go. We have that. Equally, you could have done this as a separate step. You might have created like an AEX like you did here, and maybe you fed that in. That also would be a feasible approach. But in this case, it's like one less step you're doing. You're just creating the imputation as part of creating the source object. Then you've got AE end date as well. One thing I'll show you, you can print those objects if you ever want to look at them. So you could print to your console, and you can see whatever options you would have had. So I could have put a filter in there. Maybe I only want serious adverse events, or only want something else. You could do that. And you can also set other parameters according to this source object. So that'll get more useful when you come to like efficacy parameters, where maybe you want to set like param code, param, things like that, or like BDS domains, but it's not so relevant for ADSL. So here what we have is the actual function. So we're taking ADSL2, we're creating an ADSL3, we're using this function derived via extreme date, which extreme just means either the highest or lowest. So here you're just taking either the highest or lowest date in this case. And we're going to create a new var, last alive date. And these are the source objects. So we can feed as many of these in as we need. So in a real study, you might have like 10, 15 different dates that you're scanning across to find the last date. And then you have to set the source date. So this is basically the AE, you called it AE here, and you're just setting what that actually represents, which true data set is that. And if you scroll right to the back, it's going to take this one basically. That's useful because you might have these source objects that are, the saying it just comes from AE, but actually you want to use a later different AE that you've changed just in some way in the script. So you might want to change that to like AE1 or whatever latest version of an interim AE that you're using. And then the mode is last, or it could be first. This is basically saying I want to take the latest date in this case. So the ADSL3, we run it. If we open up AE, we can just do a quick comparison. So let's have a look at first 3 records are patient 1015. Let's have a quick look at those dates. Quick scan. So the latest date should be 2014 0111. So ADSL3, let's look at that same patient. And there you go, 2014 0111 is the last date. So yeah, that's the last known alive date. Okay, we only have 20 minutes, so I'm just going to show you something quick. We're not going to have time to practice this in this workshop, but I want to show you something which is a really cool further way to have flexibility when you're using Admiral. And you can go away and practice after this. Phil will correct me if I'm wrong, but I think the POSIT Cloud stays open for a little bit of time, so you could continue to kind of practice some of these.
That's a great question.
Yeah.
The POSIT Cloud will be available to the attendees as long as they like to use the classroom. Yeah, there's no plans to spin those down or anything.
Perfect. Thanks, Phil.
Yeah.
So if you go to the user guides, so a lot of the user guides are specific around like a certain atom or a type of atom. So like exposure, for example, or time to event, questionnaires. But if you go to these advanced user guides, there's actually a lot of like specific topics which are really useful. And some of them are kind of generic. You're going to kind of have benefit from reading these to kind of make Admiral more flexible to your needs. The one I'm going to show you here is higher order functions. And this has got a selection of free functions. I'm only going to really go into two of them because I think they're two of the most useful parts of Admiral, because really Adam is endlessly diverse. We can be asked to do any kind of protocol specific, study specific derivations, and you're not always going to find like exactly what you need in the Admiral functions. So some of these kind of show where you can do things slightly different that can offer a whole lot of value. So one of them is called restrict derivation. So quite often you might want to derive something, but you only want to derive it on a subset of the input data. So imagine you're creating a post-baseline flag or something like that. You obviously wouldn't want to flag anything pre-baseline. So you could actually do a filter clause in that derivation function to make sure it only acts on records that you need. And a slice derivation is similar, but it basically says you might want to do slightly different derivations for different records in the same data set. So, the pre-baseline records may have, you may want to impute to the last date possible, but the post-baseline records, you may want to impute date to the earliest possible. So a slice derivation means you can actually run the same function, but you can give specific arguments for specific filters of that data set. So if we go through just some examples, here when we're doing restrict derivation, we're basically calling this Admiral function. We're going to use all of these arguments. These are the arguments we're going to submit to that function, but we're only doing it when study day is greater than 1 or greater than equal to 1. So all of the other records are not going to get this variable derived. They'll just have it as NA. Or slice derivation, an example could be, here we're running this function, we're using these arguments, but actually for study day greater than equal to 1, we're going to order it this way, and we're going to select mode first. But for all the other records, we're actually going to do something very different. We're going to order it by these, and we're going to do a completely opposite. We're going to filter it on, we're going to sort it on the last possible. So quite often in Adam, your derivations are kind of similar across the domain, but then you get some like real study specific pieces where you do actually need to tweak. So using some of these higher order functions, which any of the Admiral functions can be called in, it just gives you that extra bit of power. So a cool thing maybe you could go away and explore is maybe use those derivations you already created today, but use slice derivation and try to change, say, how it acts for male patients versus female, for example, or patients that are a certain age category, and try different arguments, feed in different arguments for each slice, each part of the data set, and see how much flexibility this brings you. This vignette obviously gives you some examples. It gives you a lot more detail of how you could potentially use these. If you go to the specific function pages themselves, it also gives you some nice examples and some more detail. But hopefully this vignette will really help you to understand why you might want to use them and the true power and flexibility that this brings you. So I guess I just show this at the end because I want you guys to delve in deeper. If you really want to become a master of using this package, there's loads of great user guides out there. There's loads of great examples for you to practice. And really, it's in kind of reading through these bit by bit and trying new things. That's when truly you become a champion of that package. And this could be for Admiral or for any of the Pharmaverse packages. So with that, I think that's the last you hear from me. I'll be glad to hear. And I pass back to Ari to close us out.
Great. So thank you so much, Ross, for going through the exercises today. And I hope everybody were able to solve some of them at least. And otherwise, I just put it in the chat as well that we have put the exercises and the solutions on a GitHub repo, where you will also be able to find the slides that we used today and some links to the Pharmaverse sites and some of the other things that we've seen today. As Ross mentioned, we have primarily gone through Admiral, and if you want to get a little bit further in the clinical reporting pipeline, there are 2 other fantastic workshops today on how you build on top of Admiral and build some awesome tables, figures, and listings. Before we end, I just want to say, thanks everybody for joining, and thanks to all the people who makes it possible for us to have a workshop on something like Admiral, Metacore, and all of these things that we now have in the open source space. So thank you all for joining, and I hope you join the next couple of sessions today and the conference next week.